So welcome to episode 2 of our Tech Talk. This time we are above the pits, the regular pits, and we visit Esslingen here with the combustion car. This year, due to Corona, all the combustion cars are stored above here. And yeah, this new rule set this year also bring big changes to the aerodynamics and allowed for a fan car. So Timothy, can you guide us through what big changes you made to your aerodynamic concept and how you implemented this new feature on your car?
Yeah, well, at first we learned about the rule change and thought that we should try it. We started off with some small fans, similar to our water fans, but quickly noticed that they don't really make any difference. So we thought we need to go hard or go home. So we installed two 6 kilowatt impellers on each side, and yeah, with that we do achieve quite a lot more downforce.
Okay, obviously this draws a lot of power from your system, so how you implemented it this electronic wise, and how long can you use the system actually?
Well, we have an extra battery for 48 volts that just powers the fans. I've got a battery over here, and then we use these red controllers to distribute the power to the fans, and yeah, we can run them for 2 laps of autocross, and then the battery temperature is at its limit and the capacity. And then for endurance we use a lower RPM so that we can use them for the whole race at medium speed.
So talking about numbers, so how much quicker does this actually make your car roundabout in a skid pad run or similar comparison?
In the skid pad run we're talking about 2 or 3 tenths.
Okay, that's quite impressive. Yeah, thank you very much for the quick insight into your car, and see you racing.
Yeah.
Okay, so new pit, new car. This time we visit DHBW Stuttgart and their FSG21. They also followed the trend and packaged their entire drivetrain inside the rim to allow for better kinematics and also allow for higher mass flow to the aerodynamics. So Nicolas, can you please explain us what changes you had to do to your brakes to allow for this highly integrated package?
Okay, so the challenge here was to fit the whole brake package into our 10-inch rim. So we couldn't just buy a regular caliper and had to develop one ourselves. So what we did is we developed an 8-piston caliper on the front axle, which has very small pistons to fit inside our rim.
Okay, compared to your FSG20, you now changed to 1 caliper instead of 2. So what was the main reason for this change compared to last year's car?
The main topic for the change was serviceability. In order to make our bleeding procedure easier, we changed from 2 4-piston calipers to 1 8-piston caliper. So you only have to bleed 1 caliper each side. Yeah.
And last question. So how did the manufacturing of the caliper look like? Of course you need pads, some seals, and also the housing itself, which is probably made of aluminum. So can you guide me through that process a little bit?
Our brake caliper is made from 2 pieces, milled from aluminum and then screwed together with 3 screws. For our pistons, we use steel pistons and specially made sealings to fit our special brake fluid, which is not the common DOT fluid, but mineral oil. And for those you have to use a special material.
Okay, so the main reason for the new fluid was probably the temperature rating, is this correct?
So with our new brake fluid, mineral oil, we reach higher maximum temperatures before boiling. So the whole aim of that was to higher our thermal capacity, so our brake lasts longer in endurance. Yeah.
Okay, thank you very much for the talk, and we hope to see you guys soon on the racetrack, and have a nice day.
Okay, thanks.